The universe is not empty. Beneath the silent glow of galaxies lies a hidden skeleton, vast, delicate, and almost impossible to see. It stretches across billions of light years, a web spun from threads of dark matter and gas, binding everything into place. This is the cosmic web, the invisible architecture of the cosmos, the largest structure humanity has ever uncovered. We look up at the night sky and see points of light, stars, galaxies, clusters, scattered across darkness, but they are not scattered at all. They are connected. They gather into filaments like dew along a spider's thread, forming a cosmic lattice that stretches from one end of the universe to the other. Between these filaments yawn immense voids, regions so empty that entire galaxies vanish within them. Together, these threads and voids create a structure larger than imagination, a pattern woven by gravity itself. And yet, for most of history, it remained hidden. Our eyes could not see it. Our telescopes revealed galaxies, but not the skeleton that bound them. Only with simulations, with maps drawn from millions of galaxies, and with the faint glow of intergalactic hydrogen, have we begun to glimpse the true design. The cosmic web is no metaphor, it is real, and it holds the universe together. This is the story of that invisible skeleton, the story of how matter flowed after the Big Bang, how galaxies were sculpted by threads of unseen substance, how dark matter and dark energy carved the geometry of space itself. It is the story of the greatest map we have ever tried to draw, and the question that haunts it: if the cosmic web is the skeleton of the universe, then what hidden forces gave it form? The birth of the web. In the beginning, there was no web. There was no structure at all, only a seething, formless ocean of energy, dense and incandescent, filling every corner of space. The universe was less than a second old, and already it was expanding at speeds beyond comprehension. Time itself had just begun. Space itself had just unfolded. And in that first instant, the seeds of the cosmic web were sown. The Big Bang was not an explosion in space. It was the expansion of space itself. Within fractions of a second, inflation stretched the newborn universe to scales vast beyond imagination, smoothing it almost to perfection. But not completely. Tiny quantum fluctuations, ripples of chance at the smallest scales, were amplified by expansion, frozen into the very fabric of space-time. These fluctuations were minute, 1 part in 100,000, but they were enough. In time, they would grow into the scaffolding of the cosmos, the faint blueprint of a structure billions of light years wide. As the universe cooled, matter began to emerge from energy. Quarks fused into protons and neutrons. Electrons swarmed around them. In the first 3 minutes, the lightest elements, hydrogen, helium, traces of lithium, were forged. Still, the universe was opaque, filled with a glowing plasma where photons scattered endlessly, unable to travel freely. For nearly 380,000 years, the cosmos was a blinding fog, uniform and featureless to the eye. But hidden in the fog were the imprints of those ancient fluctuations. Regions slightly denser than average exerted slightly stronger gravity. With time, they would begin to pull, to gather, to stretch. When the fog finally cleared, light was released into the cosmos. We call it the cosmic microwave background, the faint afterglow of creation, still detectable across the sky. In its delicate patterns, we can see the fingerprints of the fluctuations. Brighter spots where matter was denser, darker where it was thinner. To the untrained eye, it looks like noise, a mottled texture of heat. But to cosmologists, it is a map, the first glimpse of the invisible web to come. Over millions of years, gravity began its patient work. Hydrogen flowed into the denser regions, gas collecting in wisps and streams. Like dew beating along the strands of an unseen net, matter drifted into filaments, amplifying the pattern that inflation had left behind. These filaments grew into rivers of gas, stretching across space, while the emptier regions grew emptier still, swelling into vast voids. Stars were born within these threads, igniting in pockets where gas collapsed under its own weight. Galaxies followed, gathering along the filaments like beads on cosmic strings. Clusters formed where filaments intersected, immense knots of hundreds or thousands of galaxies bound together. The universe was no longer a smooth sea. It was becoming a web, delicate yet immense, an architecture that stretched from horizon to horizon. We cannot see dark matter, yet it was the silent architect of this design. Though invisible, it outweighed normal matter 5-1, shaping space with its gravities bound together. The universe was no longer a smooth sea. It was becoming a web, delicate yet immense, an architecture that stretched from horizon to horizon. We cannot see dark matter, yet it was the silent architect of this design. Though invisible, it outweighed normal matter 5-1, shaping space with its gravity. Ordinary gas and stars were only the tracers, glowing along the scaffolding that dark matter built. Without it, the web could not exist. With it, the cosmic skeleton took form. The birth of the web was not sudden. It was the slow unfolding of gravity's dance, a billion-year ballet that transformed chaos into order. By the time the first galaxies had settled into spirals and clusters, from randomness came pattern. From silence came the skeleton of everything. And even now, as we gaze into the night sky, we are only beginning to trace its outlines, only beginning to glimpse the threads that bind us to the cosmos, mapping the invisible. The cosmic web is vast beyond measure, stretching across the observable universe, but for most of history it remained hidden. What we could see were the stars above, a scattering of points across a dark dome. Through telescopes, we learned that those points were suns, and beyond them galaxies, and beyond those galaxies entire clusters. Yet no matter how powerful the lens, no eye could glimpse the threads that connect them. The web was invisible, a skeleton veiled behind the light of the cosmos itself. To map it, we would need more than sight. We would need patience, imagination, and the power of collective vision. The first clue came not from observation, but from theory. Gravity, relentless and impartial, does not act randomly. It pulls more strongly where matter is denser, drawing material together over time. Cosmologists realize that the slight fluctuations preserved in the cosmic microwave background would, under gravity's hand, evolve into structure. Galaxies should not be scattered like grains of sand, but arranged in patterns, connected in ways too vast to see in a single glance. Yet prediction alone was not enough. To glimpse the web required surveying the universe on scales never attempted before. In the late 20th century, astronomers began to map galaxies by the tens of thousands. Each dot was a galaxy. Each galaxy a collection of billions of stars, and when plotted together, a pattern began to emerge. They did not form a uniform mist. They gathered into chains and walls, leaving great voids in between. The map resembled lace, or coral, or the delicate structure of living tissue. This was the first glimpse of the cosmic web, not through a telescope pointed at a single object, but through the collective cartography of the sky. The Sloan Digital Sky Survey, launched in 2000, transformed this effort. With a dedicated telescope in New Mexico, it charted over 1 million galaxies, revealing structures hundreds of millions of light years long. The data showed immense walls of galaxies, such as the Sloan Great Wall, stretching across space like continental ridges in a cosmic ocean. Between them lay voids so vast they could swallow entire superclusters. For the first time, humanity held a map of the universe's skeleton, drawn not in stars, but in galaxies, each a point of light along invisible threads. Simulations confirmed the picture. By programming the laws of physics into supercomputers and letting them evolve a universe of their own, scientists watched matter flow under gravity's pull. The results were astonishing. Vast webs of filaments formed naturally, dark matter flowing like rivers, galaxies forming like sparks along the current. These digital universes matched our maps of the real one with uncanny accuracy. It was as though the cosmos itself had been recreated in silicon, its skeleton revealed in glowing threads of simulated matter. Yet even with millions of galaxies charted, the true web remained partly hidden. For galaxies are only tracers, bright markers of something deeper. The real architecture lies in the invisible dark matter, the silent framework that outweighs all the stars combined. How could we map what cannot be seen? The answer came from light itself, bent by gravity as it travels through space. This phenomenon, called gravitational lensing, allows astronomers to detect the subtle distortions caused by dark matter's mass. By collecting and analyzing the faint warping of distant galaxies, we can trace the contours of the invisible, mapping the hidden scaffolding that shapes the universe. Bit by bit, the unseen becomes seen. Even the thin gas between galaxies offers clues. Using sensitive instruments, scientists detect the faint glow of hydrogen stretched along filaments, illuminated by ultraviolet light from galaxies and quasars. These whispers of intergalactic gas confirm that the web is not just mathematical, not just gravitational, but real. Threads of matter stretching between galaxies, binding them into a structure larger than any we can easily imagine. The act of mapping the invisible is humbling. It requires not just telescopes, but cooperation across nations, decades of patience, and faith in patterns too vast for any one human mind to grasp. When the data is gathered, when the maps are drawn, the result is breathtaking. A universe that looks less like chaos and more like a living organism, a web of veins and arteries pulsing with galaxies. It is as though the cosmos itself were alive, its skeleton hidden until now. And yet, for all our progress, we have charted only the beginning. Our surveys reach billions of light years, but the universe extends farther still. Beyond the horizon, beyond the reach of our light, the web continues, infinite or nearly so, a pattern without end. We map what we can, and in doing so, we glimpse the immensity of what remains unseen. To map the cosmic web is to confront our own smallness, not in despair, but in awe. For in the threads of galaxies and dark matter, we find the echo of those first quantum ripples, stretched across time into a skeleton that holds us all. The dark matter threads. The cosmic web is not woven from stars. Its threads are not spun from the luminous fabric of galaxy. What gives the universe its skeleton is something far stranger, something we cannot see, something that passes through us at every moment without leaving a trace. It is called dark matter, and it outweighs all the stars, all the planets, all the visible material of the cosmos 5 to 1. Without it, the universe, as we know, it would not exist. Without it, there would be no web, no galaxies, no us. Dark matter is invisible because it does not interact with light. It cannot be seen in a telescope, photographed in a lab, or held in the palm of a hand. Yet its presence is undeniable. Galaxies spin too fast to be held together by their stars alone. Without extra mass, they should fly apart. Clusters of galaxies bend light more strongly than visible matter accounts for, curving space-time with invisible weight. The afterglow of the Big Bang carries subtle imprints of a hidden mass that shaped its ripples. Every observation converges on the same truth. Something unseen dominates the universe, and it has been there from the beginning. It is this dark matter that forms the threads of the cosmic web. In the early universe, it clumped under its own gravity, forming vast filaments long before stars were born. Ordinary matter, gas, dust, the atoms that make up our world, flowed along these filaments like water filling a channel, gathering where dark matter had already carved the path. Galaxies ignited along these currents, not randomly, but precisely where the invisible threads had drawn them. We see galaxies glowing in space, but they are lanterns hung upon scaffolding we cannot see. The true structure of the universe lies beneath the light, in the dark. Computer simulations reveal this hidden framework with eerie beauty. When vast quantities of dark matter are allowed to evolve under gravity's law, they stretch into filaments that crisscross space, leaving behind yawning voids. Add gas and stars, and the galaxies appear exactly along those filaments, as though pinned in place by invisible strings. It is the dark matter that gives the web its form, and the galaxies that make it visible. In truth, the universe is like a shadow play. The light we see is only the silhouette, cast by an invisible structure behind it. And yet, for all we know of its role, we do not know what dark matter is. Countless experiments have tried to detect it directly, searching for particles passing through underground detectors, looking for signs of annihilation in the skies, probing every clue. Decades of searching have given us no definitive answer. We know it must be there, but we do not know its substance. Is it made of weakly interacting particles, born in the furnace of the early universe? Is it something even stranger, something beyond our physics, a shadow field woven into space-time itself? Until we know, the cosmic web remains half-mapped, half-understood, a skeleton with bones we cannot identify, a web so haunting. Every time we look at a cluster of galaxies, we are looking at the fingerprint of dark matter. Every filament we map, every void we measure, is evidence of an invisible force sculpting the cosmos. Our very existence is owed to it. Without the threads of dark matter, gas would not have gathered. Stars, the atoms in our bodies flowed along invisible highways before they ever found their way into a star, a planet, or a human heart. We are, quite literally, children of the dark. The web is not static. It evolves, shifting slowly as gravity continues its patient work. Filaments draw matter inward. Clusters grow more massive. Voids expand. Dark matter continues its silent task, shaping the future just as it shaped the past. And all the while, we remain unable to see it directly, able only to trace its contours through the galaxies it binds and the light it bends. It is a reminder that reality is not limited to what most important structures in the universe are hidden, invisible, known only through their influence. To speak of the cosmic web is to speak of dark matter. The two are inseparable. The luminous skeleton we glimpse in our surveys is only the faintest reflection of the invisible one beneath. The galaxies are sparks along a deeper fire, signals carried on unseen wires. In the end, the web reminds us of a truth as humbling as it is profound, that most of the universe is hidden, that what we call reality is only the surface, and that beneath it lies a darkness vast and patient, weaving the structure of everything we know. The voids between. If the cosmic web is a skeleton of threads, then it is defined as much by its absences as by its presence. For between the glowing filaments, between the clusters of galaxies bound in knots, lie regions so empty they defy imagination. These are the cosmic voids, vast expanses where galaxies are scarce, where matter itself is rare, where darkness reigns not because of hidden substance, but because there is almost nothing at all. They are the negative space of the universe, the silence between its notes, the hollows that give shape to the web. At first glance, one might expect the universe to be full everywhere, its galaxies evenly scattered like grains of sand across a beach. But the deeper we map the sky, the clearer it became. Galaxies are not spread evenly. They are arranged along the edges of emptiness. The voids stretch for hundreds of millions of light years, some so large they could contain thousands of Milky Ways and still seem barren. From within them, the night sky would look impoverished, sparse, as though the universe itself had thinned. These voids are not absolute nothingness. A few lonely galaxies do drift within them, small and isolated, their formation stunted by the lack of matter around them. Gas there is thinner, stars rarer, and evolution slower. To exist in a void is to live apart from the great currents of the cosmos, to grow without neighbors, to shine alone. Astronomers call these lonely wanderers void galaxies, and they are windows into what the universe might have been had the web never formed. Sparse, dim, and empty. The voids exist because gravity amplifies difference. Where matter was slightly denser in the early universe, it pulled more material toward itself, forming filaments and clusters. Where it was slightly less dense, gravity pushed matter away, leaving regions ever emptier. Over billions of years, the rich grew richer and the poor poorer. Filaments fattened and voids swelled. Today, the universe resembles not a uniform sea, but a sponge, its great cavities surrounded by threads and walls of galaxies. The web's shape is as much about emptiness as it is about fullness. For cosmologists, voids are not simply gaps. They are laboratories. Because they contain so little, they are less tangled by the complexity of galaxy clusters, less disturbed by local noise. They are pure expressions of cosmic expansion, places where the influence of dark energy, that mysterious force driving the acceleration of the universe, can be felt most clearly. By studying the shapes and sizes of voids, scientists hope to measure the fingerprints of dark energy itself, to glimpse how it stretches the universe apart. In emptiness, the deepest truths of cosmology may be revealed, and yet the voids stir something beyond science. There is an existential weight to their vastness, a reminder of how fragile our corner of the universe truly is. Our galaxy lies along a filament, rich with neighbors, surrounded by clusters and walls. But had we been born in a void, perhaps we would never have known the grandeur of the cosmos. Perhaps we would have looked into a star-poor sky and imagined ourselves alone, never suspecting that just beyond the darkness stretched a web of galaxies too far away to reach us. To stand beneath the night sky, even here, is to look into a cosmic paradox. The stars dazzle, filling the eye with light, and yet they are outnumbered by the darkness between them. The same is true on the grandest scales. The web is defined not only by its threads, but by its gaps, the voids that shape its geometry. To understand the universe is to understand both, the filaments that bind and the emptiness that divides. The cosmic voids are reminders that structure is born from contrast. Without emptiness, the web would not exist. Without silence, music would be noise. Without darkness, stars would have no stage on which to shine. The universe, in its vastness, is not only a story of what is present, but of what is absent. And in the spaces between, we find the outlines of the whole. Galaxies along the threads. The filaments of the cosmic web are more than empty scaffolds. They are rivers of matter, channels along which galaxies are born and drawn together. To look at the web is to see not just structure, but history, the story of how the universe assembled itself, one galaxy at a time, along the threads of an invisible skeleton. The galaxies are like lanterns strung along a dark lattice, their light tracing the pathways of forces they cannot see. Within these filaments, hydrogen flows, feeding the growth of stars. In the early universe, these rivers of gas were abundant, cool enough to collapse, but vast enough to stretch across millions of light years. Along them, knots formed where filaments intersected, and within these knots, galaxies ignited like sparks. The Milky Way itself is one such spark, born at the crossing of filaments, drawn into a web whose architecture was set long before it began to shine. Galaxies along the threads are not evenly spaced. They cluster where gravity knots the strands, forming groups and superclusters. Some filaments are thick with galaxies, glowing like illuminated highways. Others are thinner, with lonely galaxies scattered like faint street lamps. The density of the thread shapes the destiny of its galaxy. In rich intersections, galaxies collide and merge, their stars mingling, their black holes uniting in violent dances. In quieter strands, galaxies evolve in relative solitude, their shapes preserved for billions of years. When we map them, a picture emerges of galaxies as social beings, never truly alone, always part of larger patterns. Even those that appear isolated often trace invisible filaments, their positions dictated not by chance, but by the dark matter threads beneath. The cosmic web is the stage upon which galaxies live. In the densest regions, galaxies grow massive and old. Gas is consumed quickly, stars burn out, and elliptical galaxies dominate, their shapes rounded, their colors red with ancient light. In the quieter filaments, spirals like our own persist, blue with the glow of young stars, sustained by steady flows of hydrogen. The environment of the web shapes not only the arrangement of galaxies, but their very character, guiding their fates across billions of years. Collisions are inevitable along the threads. Gravity draws galaxies together, and when they meet, the result is spectacular. Stars are flung into tidal tails, gas compresses into bursts of new star formation, and central black holes awaken as quasars, blazing brighter than entire galaxies. These collisions are not random, but orchestrated by the web itself, which funnels galaxies into its intersections. The brightest lights of the universe, the most violent events we know, are staged along the filaments of the cosmic skeleton. Our own Milky Way belongs to this pattern. It is part of the local group, a collection of galaxies bound together along a filament of the web. That filament itself connects to larger structures, to the Virgo cluster, to the Laniakea supercluster, a vast basin of attraction where thousands of galaxies flow like rivers toward a common center. When we map our position in this cosmic geography, we see that even here, even now, we are not adrift, but anchored to the threads of the web. And still, the galaxies are only markers. The true filaments are dark matter, unseen but omnipresent, guiding the flow of baryons, the ordinary matter that forms stars. Without dark matter, galaxies would drift apart, scattered like dust. With it, they coalesce, forming chains and clusters that stretch across space. To watch galaxies along the threads is to watch a dance choreographed by an invisible partner, each step dictated by gravity, each motion part of a larger design. The web is not static. Galaxies continue to move along its strands, pulled toward the knots where filaments intersect. Over billions of years, clusters grow richer, filaments grow sharper, and voids widen. The galaxies are like beads sliding along wires, drawn ever inward. In time, collisions will erase spirals, leaving behind massive ellipticals in the densest region. The web evolves, and so do its lanterns. Yet there is a strange beauty in the arrangement. When astronomers plot millions of galaxies, the maps resemble living things. Neurons branching, roots spreading, rivers winding across continents. The universe, in its largest structures, mirrors the forms of life itself. The galaxies along the threads shine like cells in a vast organism, their light the pulse of something greater than themselves. It is as though the cosmos carries within it the same patterns that echo through forests, rivers, and mines. The galaxies tell us that the web is not a metaphor, but a reality, that the largest structures of the universe are as intricate as the smallest. They remind us that our home is not isolated, but connected, that every star we see is part of a lattice billions of years in the making. To trace the threads is to trace our own history, to see how the hydrogen in our blood once flowed through filaments, how our galaxy took its place in the grand design, how light itself marks the path of an invisible skeleton. The cosmic web is a map, but it is also a mirror. When we see galaxies along its threads, we are looking not just outward, but inward, glimpsing the architecture that shaped us. For without these threads, without these filaments of dark matter and gas, there would be no galaxies, no stars, no life to wonder at the sky. The galaxies are beads of fire strung along the dark strings of the cosmos, and their light reveals the hidden skeleton on which everything rests, the cosmic web in motion. The cosmic web may look like a frozen lattice, a snapshot of threads and knots stretched across eternity. But it is not still. It is alive with motion, evolving across billions of years, shifting under the ceaseless pull of gravity and the relentless push of expansion. To imagine it frozen is to mistake the photograph for the dance. The web is not static. It flows, it stretches, it changes, and in its slow motion lies the story of the universe itself. From the first moments after the Big Bang, matter has been in motion. The initial fluctuations were tiny, barely perceptible ripples in the plasma of the newborn cosmos, but gravity turned those ripples into rivers. Slightly denser regions began to pull, drawing gas and dark matter toward themselves. The filaments stretched, knots thickened, voids emptied. This was the first stirring of the web, the slow unfolding of a pattern that would span the universe. As galaxies formed, They did not remain where they were born. They slid along the threads of dark matter like beads on invisible strings, pulled ever inward toward intersections. Superclusters grew from this migration, vast gatherings of galaxies moving toward common centers of gravity. Our own galaxy is part of this motion. The Milky Way, along with thousands of others, is flowing toward a gravitational basin called the Great Attractor, a mysterious region where filaments converge. On these scales, space itself becomes a river, and galaxies are boats carried by its current. Yet gravity is not the only force shaping the dance. In the late 20th century, astronomers discovered something astonishing. The expansion of the universe is not slowing, as gravity would suggest, but accelerating. Some unknown energy, filling space itself, is pushing galaxies apart, stretching the web wider and wider. We call it dark energy, and though we do not understand its nature, we can see its effects. The filaments still pull matter inward, but the spaces between them grow ever larger. Clusters tighten while voids expand. The web is caught between two cosmic forces, gravity knitting it together, dark energy pulling it apart. This tension defines the motion of the web. In dense regions, gravity wins. Filaments collapse into clusters, galaxies collide, and the web thickens into luminous knots. In sparse regions, dark energy dominates. The voids grow emptier, their edges receding at increasing speed. On the grandest scales, the universe becomes both more structured and more diffuse, its skeleton sharpening even as its limbs are pulled apart. Simulations reveal this paradox with haunting clarity. Run the clock forward in a digital universe, and the filaments become more pronounced. Clusters swell with galaxies, fed by rivers of matter streaming inward. But beyond them, the spaces widen. Billions of years from now, galaxies not bound to our local web will slip beyond our horizon, carried away faster than light by the acceleration of space. The cosmic web will persist, but it will become an island, a structure surrounded by unreachable darkness. The dance will continue, but fewer dancers will remain in view. On smaller scales, the motion of the web shapes the lives of galaxies. Streams of hydrogen flow along filaments into galaxies, fueling star formation. When galaxies collide at intersections, their stars mingle and their black holes merge, sending ripples of gravity through space-time. Even the spin of galaxies is influenced by the web. Recent studies suggest that spiral galaxies align their rotation with the filaments that cradle them, their very motion written by the threads of dark matter. The cosmic web is not just the stage, it is the choreographer guiding every step of the dance. And still, we are only beginning to trace this motion. Our maps are snapshots, frozen in time, limited by the speed of light. When we look into space, we look into the past. The galaxies we see are millions or billions of years old, their light delayed in its journey to us. To watch the web in motion, we must stitch these snapshots together, comparing the nearby universe with the distant one, reconstructing its evolution like frames in a film. In doing so, we glimpse the story of change written across cosmic time. It is humbling to realize that even now, the web is moving around us. Our galaxy drifts at hundreds of kilometers per second relative to the cosmic microwave background, pulled by the gravity of unseen clusters. The local group, the Virgo cluster, the Laniakea supercluster, all are flowing, merging, reshaping. We do not stand still within the web. We are swept along by its currents, carried on a journey that began before the Earth was born, and will continue long after it is gone. The cosmic web in motion is a reminder that nothing in the universe is fixed. Structure is always becoming, always evolving, always in flux. The threads of dark matter are not rigid bones, but living rivers, bending and stretching with time. The galaxies are not static lights, but travelers, migrating along paths written in gravity. Even the voids, vast and silent, are expanding, reshaped by the push of dark energy. Everything flows, and in the flow lies the truth of the universe, that it is not a place, but a process. To see the web as motion is to see it as alive. Not alive in the way of cells or organisms, but alive in its continual unfolding, its ceaseless change. It is a skeleton that builds itself, a dance that creates its own dancers, a story without end. And as we trace its currents, we begin to glimpse not only the architecture of the cosmos, but the rhythm of its becoming. Echoes of the early universe. The cosmic web, vast and intricate as it is today, carries within its structure the memory of its birth. Like scars left on stone, like the grain of wood that remembers the growth of the tree, the web preserves echoes from the earliest moments of time. To study it is to look backward, to trace the fingerprints of the Big Bang across the skeleton of the universe. Nearly 14 billion years ago, before galaxies, before stars, before atoms had even bound themselves together, the universe was a furnace of energy and plasma. In that glowing chaos, tiny fluctuations flickered into being, ripples in density born from the restless uncertainty of the quantum world. Inflation magnified them, stretching them to cosmic scales, freezing their imprint into the fabric of space. These ripples were faint, 1 part in 100,000, but they were enough. They were the seeds from which the web would grow, the hidden pattern beneath everything we see today. We glimpse those seeds in the oldest light we know, the cosmic microwave background. When the universe was 380,000 years old, the plasma thinned, the fog cleared, and photons were released to travel freely. That light, stretched now into microwaves, still washes across us from every direction. In its delicate modeling, its tiny variations in temperature, lies a portrait of the infant universe. What looks like static to the eye is, to the trained mind, a blueprint of destiny. The brighter spots show where matter was denser, the darker where it was thinner. Over billions of years, those faint ripples became galaxies, filaments, clusters, and voids. The microwave background is not just a relic of the past. It is the first map of the web itself. Later, the universe echoed again. As it expanded and cooled, sound waves rippled through the hot plasma, compressing and rarefying matter in vast, spherical shells. These baryon acoustic oscillations, as they are known, left their imprint on the distribution of galaxies we see today. Stretching across 500 million light-years, they are faint ripples in the web, a fossilized memory of sound waves frozen into space. When we measure the spacing of galaxies, we can still detect them, a rhythm from the dawn of time, preserved in the architecture of the cosmos. Even the dark matter threads themselves are echoes. Though we cannot see them, we know they were shaped by the same primordial fluctuations that sculpted the microwave background. Simulations begin with those faint ripples, and under the pull of gravity, allow them to grow into the structures we observe. The match is uncanny. The same patterns visible in the sky's oldest light are written into the filaments and voids around us today. It is as though the web is a fossil, a record not of bones or shells, but of the universe's own heartbeat. Galaxies, too, remember their origins. The chemical elements within their stars tell the story of early nucleosynthesis, when the first atoms formed in the newborn cosmos. Their clustering reveals the hand of dark matter, whose presence was already shaping space long before the first star was born. Even the great superclusters and empty voids trace back to those initial fluctuations, amplified by time but unchanged in essence. The universe we see today is the matured form of a pattern laid down when it was less than a heartbeat old. And so, when we gaze into the cosmic web, we are not merely seeing the present. We are seeing the past stretched into the present, the echo of the earliest vibrations written across billions of light years. The filaments are ancient sound made visible. The voids are silences expanded by time. The clusters are the densest beats in a rhythm that began at creation. The web is not just a skeleton. It is a memory, a structure of remembrance that holds within it the story of the beginning. In the end, this is perhaps the most haunting truth of the cosmic web, that we do not merely exist within it, but that it carries the echo of our origin. The same ripples that shaped galaxies shaped us. The same fluctuations that bent hydrogen into filaments eventually bent starlight into DNA, neurons, thought. To map the web is to map our own ancestry, to trace the chain of cause and effect back to the first trembling of space itself. The universe remembers. And it remembers in structure, in pattern, in the silent threads that hold everything together. The cosmic web is the echo of the early universe, the visible skeleton of a dream that began with a single breath of creation. The future of the web, the cosmic web, is not finished. Though it appears eternal, stretched across the sky in patterns too vast to change, it is still evolving, still caught in the tension between gravity and expansion. Its past is written in the microwave background, its present in the clustering of galaxies, but its future remains unwritten, a story that will unfold over trillions of years. To imagine it is to step beyond human lifespans, beyond the age of stars, into a time when the web itself will fade. For now, gravity continues its work. Filaments draw galaxies inward, feeding clusters that grow heavier with each passing billion years. Collisions still occur, galaxies merging into giants, black holes uniting at their cores. In the dense knots of the web, this process will continue, forming ever larger structures. Our own local group, including the Milky Way and Andromeda, will merge into a single massive elliptical galaxy, drifting eventually toward the greater gravitational basin of the Virgo cluster. Across the web, similar mergers will play out, reshaping its intersections into colossal galactic cities. Yet while gravity knits locally, expansion rules the whole. Dark energy, the mysterious force driving the universe's acceleration, ensures that galaxies not bound to one another will drift apart faster and faster. Already, distant galaxies recede from us beyond the speed of light, their light forever out of reach. In the far future, only the galaxies of our local web will remain visible. The rest will vanish beyond the cosmic horizon, their filaments pulled away into darkness. The cosmic web will not disappear, but it will fragment, breaking into isolated islands adrift in an endless sea. As time stretches on, stars will exhaust their fuel. New stars will still form for trillions of years as gas clouds collapse, but eventually even the richest filaments will run dry. Star formation will cease, galaxies will fade, and the web will dim. The skeleton will remain, its dark matter threads intact, but the lanterns that mark it, the galaxies, the stars, the glowing gas, will wink out one by one. The cosmic web will persist, but it will become invisible, a silent framework of dark matter stretching across space with no light to reveal it. Beyond even that lies a stranger future. Black holes, the remnants of collapsed stars and galaxies, will dominate the web's knots. Over unimaginable spans, they will evaporate through Hawking radiation, dissolving into particles and leaving emptiness in their wake. The filaments will remain as structures of dark matter, but even dark matter may not be eternal. Some theories suggest it will decay particle by particle until the web itself unravels into uniform darkness. And yet, the future is not only an ending. The web teaches us that structure is born of contrast, that filaments rise because voids fall, that galaxies form where rivers of matter converge. If dark energy is not constant, if its nature changes across time, the future of the web may differ from our prediction. Perhaps acceleration will slow, allowing filaments to reconnect. Perhaps new physics will alter the balance, reshaping the skeleton in ways we cannot imagine. The fate of the web is a mystery as deep as its origin, a question that lies at the frontier of cosmology. Still, in the visions we hold today, one thing is clear. The cosmic web is not permanent. It is a phase, a chapter in the universe's story. We live in a time of light, a time when galaxies blaze along the filaments, when the skeleton is visible against the dark. But this time is brief compared to the life of the cosmos. We are witnesses to a moment when the web is young enough to glow, old enough to be vast, fragile enough to be mapped. In the deep future, such a view will be impossible. The web will fade from sight, and only memory will remain. To think of this is not to despair, but to marvel, for it means that we live in a privileged era, when the universe reveals its skeleton to us, when light still marks the threads, when maps can still be drawn. Billions of years from now, future observers, if any remain, will see only a dim island of galaxies, unaware of the great web beyond. They will believe themselves alone in the dark, never suspecting the grandeur that once was. We, here and now, are among the few who will ever know the truth. The future of the web is a story of fading, of fragmentation, of silence. Yet it is also a story of endurance. For even as light fails, the structure will persist, written into space-time itself. The threads may grow invisible, but they will not vanish quickly. They will endure for eons, the last memory of a universe that once blazed with galaxies, the lingering skeleton of a dream that began at the dawn of time. And perhaps, in some form, the web will outlive even the stars. Perhaps its dark matter threads will remain long after all else has dissolved. A ghostly lattice stretching across emptiness, a silent reminder that the universe once had form, once had light, once had life. The future of the web is uncertain, but one truth is sure. It will not remain as it is. It will change, as all things change, until even the skeleton of the cosmos is but an echo fading into darkness. The web and us. We often look at the cosmic web as something distant, a structure too vast to touch us, a pattern that belongs to the farthest galaxies and the deepest void. But in truth, it is the reason we exist. Our galaxy, our solar system, the atoms in our bodies, all are threads woven into this skeleton. We are not apart from it. We are expressions of it, sparks that flared along its filaments, fleeting lanterns of life suspended on an ancient lattice of dark matter and gas. Every element in us was shaped by the web. Hydrogen, the first and simplest atom, flowed along filaments in the early universe, gathering into rivers of gas. Within them, stars ignited, fusing hydrogen into helium, helium into carbon, oxygen, iron. When those stars died, they scattered their elements into space, seeding the galaxies with the ingredients of life. The carbon in our cells, the calcium in our bones, the iron in our blood. All of it was carried by the currents of the cosmic web, guided by the invisible threads of dark matter, shaped by the same forces that sculpted the universe. Our very galaxy is a child of the web. The Milky Way was born where filaments converged, at an intersection rich with gas and dark matter. It grew by drawing material from the threads around it, by merging with smaller galaxies that drifted along those same paths. Even now, the Milky Way is not static. It continues to pull from the web, its stars nourished by streams of gas funneled through filaments. The same invisible rivers that shaped the first galaxies continue to sustain ours across billions of years. And beyond our galaxy, our place is even clearer. The Milky Way is part of the local group, a gathering of galaxies drawn together by the web's gravity. That group itself belongs to the Virgo cluster, and that cluster to the Laniakea supercluster, a vast basin where thousands of galaxies flow toward a common center. When we map our cosmic address, we see not isolation, but belonging. We are part of a hierarchy of structure, from the smallest star to the largest web, each nested within the other. To know ourselves is to know this lattice, to see the skeleton that holds us in place. Yet there is something deeper still. The web is not only our origin, but our mirror. When we trace its filaments, we find patterns that echo within us, branching like neurons, sprawling like roots, flowing like rivers of blood. The largest structures in the cosmos resemble the smallest structures in our minds. The universe, in its architecture, seems to repeat itself, weaving the same designs across. Or perhaps it is a hint that the fabric of reality carries principles we have only begun to glimpse, principles that unite the macrocosm and the microcosm, the skeleton of the universe and the skeleton of thought. For humanity, the web is both humbling and empowering. It humbles us because it dwarfs us beyond measure. The filaments stretch for billions of light years, while our lives span scarcely a century. To stand beneath the night sky is to confront the immensity of a structure that cares nothing for our existence, that has unfolded since long before life began. And yet, it empowers us because we can see it. From a small planet circling an ordinary star, we have mapped the largest structure in the universe. We have traced the invisible, revealed the hidden, drawn the skeleton of the cosmos from faint whispers of light. That we can comprehend the web at all is a testament to the strange power of consciousness, itself a product of the web's unfold. The web and us are not separate. We are filaments within filaments, patterns within patterns. Our lives are brief sparks, but they are made of atoms forged in the web's furnaces, carried by its currents, shaped by its gravity. To look at the cosmic web is to look at our own ancestry, our own architecture, our own reflection cast at a scale so vast it staggers the imagination. Perhaps in the end, this is its greatest gift, to remind us that we belong, that in a universe so immense, so cold, so ancient, we are not adrift, but anchored, anchored to threads we cannot see, to a skeleton that binds galaxies and people alike, to a structure that has carried us from the first breath of creation to this moment of awareness. The cosmic web is not distant. it is home. Epilogue: the skeleton of dreams. The night sky has always been a mystery, a canvas scattered with light, a question written in fire. For millennia, we looked up and saw only points, distant and unconnected, stars painted against a black dome. We did not know they were part of something larger, something hidden, something vast beyond imagination. Now we know. The stars are not scattered. They are strung along threads, woven into filaments, bound into clusters, arranged upon an invisible skeleton. The cosmic web is the greatest map we have ever drawn, the largest structure we have ever uncovered. And yet, it is not distant. It is not separate. It is the framework within which we live. Our galaxy hangs upon its threads. Our sun was born from its currents. Our bodies are built from atoms carried by its rivers. We are woven into its lattice, sparks of awareness flickering along the bones of the cosmos. And still, for all our maps, the web remains mysterious. Its threads are spun from dark matter, a substance we cannot see. Its future is shaped by dark energy, a force we do not understand. Its form was seeded by quantum ripples, whispers from a time before time. To look at the web is to confront both knowledge and ignorance, to see how much we have uncovered and how much remains beyond our reach. Yet perhaps this is the point. The web reminds us that reality is layered, that what seems empty may be full, that what seems chaotic may be patterned. It shows us that we are part of something larger, something older, something fragile and beautiful. And it whispers that the universe, for all its vastness, is not meaningless, but connected, stitched together by threads invisible but real. The skeleton of the universe is also the skeleton of dreams. It is what allows stars to form, galaxies to cluster, life to awaken. It is the silent architecture of possibility, the hidden framework upon which every story is told. To awaken to it is to realize that we are not lost in the cosmos but found within it, that our brief lives are woven into a structure that spans eternity. One day, the web will fade, the galaxies will burn out, the filaments will grow dark, the skeleton will vanish into silence. But here, now, it is alive with light, alive with motion, alive with thought. And in this fleeting moment, we can see it. We can know it. We can marvel at the fact that the universe has revealed its skeleton to us, dreamers made of stardust, fragile beings of brief years standing beneath an eternal sky. The cosmic web is not only out there, stretched across the heavens. It is within us, carried in our atoms, mirrored in our minds, reflected in our wonder. And when we ask what it is, we are really asking what we are: threads of matter, sparks of awareness, fleeting lanterns along an invisible skeleton. The universe dreamed, and the web was born. The web dreamed, and galaxies flared. Galaxies dreamed, and stars gave birth to life. And now life dreams, and the universe awakens to itself. This is the skeleton of dreams. This is the invisible web that holds us all.